Good morning, everyone. This is Cadet Pimentel. Me and my group mates are going to discuss a specific topic from the course NAV 316. Our topics first is to determine the procedure in designing a predefined route plan using table and validate. Second is to create predefined route plan using the table and validate. So, for voyage planning using an ICDIS is the same as with paper-based navigation. However, making a passage plan utilizing the full aspect of a type-specific ICDIS needs some careful consideration. First, the second officer creates the draft plan. Second, master studies entire route suggests improvements, eventually approves the final plan. Third, all deck officers require a briefing on the plan. To be continued by my group mate.
Good morning guys. Report ko bahin sa appraisal. So, appraisal is ang first step niya kay this stage of plan is aim to identify that the required electronic charts are available and correct date up to date and all other relevant for publications indicated a paper or electronic are available and up to date. So, meaning niya kinahanglan na mo mga basis sa electronic sa chart pagkuha niya kinang up to date, kinang di malapas or kuha kanang wahi. The second step is safety control should be established and information relating to weather, currents, tides, chart, the tomb, drop speed, environmental limits, air draft, squat, and general hazards such as traffic concentration should be prepared and made available. So kaning manginani siya silbi na adong donggo kinahanglan mo paano gid mo mga safety hazard silbi nang may mga kuan ba nang umabot nga sa inyong agianan nga marag sa nagsabot may na traffic separation may nana ba. In the third step is the concept of safety controls is the key function specific to electronic charts. The whole city passage dependent on information being correct. So if the navigator fails to set the correct incident might occur. So kaya siya para na siya affect na siya kung may masayop ninyo bulyas o tanan nangan safety jud permanente. Second is the safety control markers distinguish between safe and unsafe water. If the navigator does not specify a safety contour, this will default to 13 meters, and when the safety contour is not displayed to a specific value set by navigator, then the safety contour is shown to the next deeper contour as the per default layers in the electronic charts. The fifth, and during route planning, indication will be made if the route is planned to cross the ship's safety contour. At the same of the monitoring, it should give an alarm if within a specified time set by the navigator own ship is likely to cross the safety contour. And the last is the division between safe and unsafe water is highlighted by chart coloring, usually blue color used to indicate unsafe areas. So that's all.
Safety contour should be calculated based on safety depth in the sum of maximum draft static plus UKC company's policy plus squat maximum height of tide. As a safety contour produces alarm, mariners should be very careful to the value that they select. The safety way is to choose a safety contour equal or greater to safety depth.
After setting the safety contour, the next task is to set up a safety domain. IMO specification requires ICDIS to trigger alarms in the following circumstances. 1. If within a specified time set by the mariner, the vessel will cross the safety contour. 2. If within a specified time set by the mariner, the vessel will cross the boundary of a prohibited area or of a geographical area for which special condition exists, no-go areas, restricted or prohibited area, na- naval exercises areas, etc. 3. When the specified cross-track limit for deviation from the planned route is exceeded, distance to be determined by mariner. 4. If continuing on its present course and over a specified time or distance set by the mariner, the ship will pass closer than a user specified distance from a danger, obstruction, wreck, or rock that is shallower than the mariner's contour or an aid to navigation.
To achieve the above, mariners should specify a safety domain for the vessel effectively contained by following parameters. 1. In depth by the safety contour, the safety depth. Second, in forward extend by the look ahead time or look ahead range. Third, in lateral closeness by specified distance. So the anti-grounding cone may also be known as a safety frame or other name dependent upon the manufacturer. It is intended for setting the size of the area that will use for the chart data analysis and for generating of the anti-grounding alarms, area alerts, or navigational alarms. The trigger points for alarm and warnings are defined by an anti-grounding cone projected ahead. Port and starboard of the vessel. The size of the anti-grounding cone will depend on ICTIS system. As well as the size, the anti-grounding cone, it will be necessary for the vessel to avoid pick-up in the delayed time to maneuver must be taken into account when setting up. The safety domain requires the navigator to input vessel voyage specific parameters, and so this must be done at this stage. Master should be consulted to determine these parameters prior install.
Planning. Passage planning on ECDIS requires almost the same procedures as for a paper chart, and navigator must follow the same best practice guideline as a pair bridge procedure guide. However, with ICDIS, the process is complicated by the fact the navigator needs to know what information is already incorporated in the ICDIS and what is not. His were a weakness of ICDIS exposed. Reference should be made to the traditional passage planning documents, printed or electronic, such as NTMC, tides and current table, less of light, sailing direction, navtext, etc. relevant to the proposed passage. Once the navigator has all the relevant documentation in hand, the plan can communicate, and first thing to check is whether waypoints or passage already exist in the ECDIS database. If so, it can be uploaded for we use by planning and initial check. The ECDIS will verify if the plan is safe for the dynamic parameter previous set.
Execution. Execution. The principles of good seamanship and maintaining a proper lookout apply when navigating electronically. Plan to use all available sources of information. Safety settings should be adjusted throughout the voyage to reflect the demands of the situation. For example, when coastal navigating, vectors, cross-track corridors, and guard zones should all be reduced. Settings such as safety contours and safety depths should be set higher for ocean passages to provide early warning of landfall, hazards, or possibility of increased traffic.
Monitoring. Do not rely solely on automatic alarms. A prudent navigator should always seek to prove the ECDIS wrong. Rather than assuming it is correct, use tools such as radar overlay RIO to assist with monitoring. An accurate RIO provides a million-point fix and allows excellent real-time monitoring, but do not rely solely upon it. Normal radar limitations still apply. Do not rely solely on GNSS input such as GPS. Cross-check frequently with other systems such as LORAN C and manual means such as visual radar fixing. Ensure that appropriate display settings are applied for coastal, ocean, and day-night navigation. Use profiles if the functionality exists.
Perils of over-reliance. Over-reliance on a single means of navigation has always been wrong. This remains true with electronic systems, including ECDIS. What are some of the perils of relying solely on ECDIS? Some issues to consider: screen fixation, tendency to become absorbed in an electronic display rather than looking out of the window. So first, failure to cross-check, tendency to assume that the displayed position is correct without verifying position integrity by some of other means. Alarm management and appropriate use of tools are critical. Example given: failure to adjust settings appropriate to the situation that may be resulting in too much or too little information. Specifically, over-reliance can be contributed by the following chart survey data, date, type, and its reliability. First, cartography. Origin, compilation, and update history of chart. Check reliability. Selection of chart data, date, data type, ENC, limitations and scale selection, how to optimize. Route planning, vessel data, and corridor widths.
Additional perils of over-reliance: measurement, settings, distance, speed, and depth. Chart symbol selection, simplified or traditional. Correct viewing skill, clutter or scamming. Orientation of display, number of deep shades, select or deselect shallow water pattern. And the next one is dependency on traditional navigation technique, include following: radar overlay, parallel indexing, position fixing including radar range, visual and clearing bearings, track history. And the last one is integration of traditional navigation techniques. These techniques remain valid and ECDIS provides a means to integrate them. It's worth considering cross-checking variety of means. Integrating ECDIS used into navigation function, looking out of window, making sense of presentation, maintain situational awareness at all times. That's all. Thank you.
And that's our report. Hope you learned something about our report presentation. And this is our group: Pasig, Ariel Casas, Pimentel, Audrey, Mibaya, John Paul, Ricanya, Marco, Sabalyap, Dave, Salido, Jerome, Salot, Elizalde, Sarona, Dwight, CB, Alison, Kyle, and Solatorio, Charlie. And that's all. Thank you, sir.